Eighth graders, this is the practice test. It looks very similar to the test that you're taking tomorrow. So make sure that you put your name and your number up at the top, up here. I'm going to collect it from you and give you a grade based on your steps and your work. Okay? So let's do problem number 1 together. You're going to solve the polynomial equation, and it's set equal to 0, so that means we're solving for roots. We're solving for what the x value is. But the first thing we do is we try to take our polynomial to its primes and see if there's anything that we can factor out. And so it looks like that we have an x in common. So I can factor out an x and get x minus 4 is equal to 0. And now I can take both pieces. You could write it like this if you wanted, so that you had a monomial times a binomial if you wanted, but you don't have to. But then you're going to set each piece equal to the 0. Whoops. Where's my erase button? Okay, so this would be x is equal to 0 and x minus 4 is equal to 0. And so x is equal to 0 is one of the answers, and then x is equal to 4 would be the other answer. So so you can write them separately, or you could do x is equal to 4, comma, 0, something like that. You could put an or something. Box your answer, of course. Okay, and now we're going to do the second problem. If 24 is added to x squared, the sum is 11x. So we have to convert that to algebra. So if 24 is added to x squared, that means you're taking x squared and you're adding 24 to it. The sum, which means add, is, which means equals, is 11x. And so now we need to solve this. So that means I need to move my 11x to the other side. So I'm going to add a negative 11x to both sides. And I get x squared minus 11x plus 24 is equal to 0. And now we have a traditional quadratic that has to be factored into two binomials. We know that by looking at the negative and the positive sign, that the insides of each of these binomials is a negative. We can make our little chart if we want to, and say it has to multiply to make 24 and add to make a negative 11. So the factors of 24 are 1 and 24. That won't add to make an 11. 2 and 12. That won't add to make 11. 3 and 8. And 3 and 8 do add to make an 11. So we're going to throw them in here. Keep our x's as our first term, and of course it's still equal to 0. So it says, what are the possible values of x? Well, the possible values of x means solve for those roots. Solve for what x is. And in order to do that, you set each piece equal to the 0, and you solve for x is 3 or x is 8. And these are your two answers. Okay, let's look at problem number 3. Number 3 says factor completely. Now notice that it's not equal to 0, so we're not solving for the roots. We just have to make sure that we factor completely. So if I look at problem number 3, I'm looking to see if I can take it to its primes and see if they have anything in common. Well, there's no x on this third term, so there's not going to be an x to be factored out. And the 5 is prime, so everything is as it is, and so we really just have to make our chart and factor it. So we know it has to multiply to make a 12. It has to add to make a 5, and the first term is multiplied to make a 2. So I'm going to say that my factors of 2 are 1 and 2, and my factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So I have to figure out which ones work. So I'm going to... Okay, so I'm going to try to combine these guys. So if I combine my 1 with my 1, I get a 1. And a 2 with the 12, I get 24. That's never going to work to make the 5. So if I do 2 with the 1 and 1 with the 12, I have a 2 and a 12, which is never going to combine to make a 5. So this guy's out. So let's look at the other ones. Try 1 with the 2. That gives us a 2. And the 2 with the 6 gives us a 12. That's never going to combine to make a 5. So try the opposite. 2 with the 2 gives us a 4, and the 1 with the 6 gives us a 6. That's never going to combine to make 5. So mine's getting a little sloppy here, so I'm going to try to erase and give us some space. So I think I've tried both combinations, so this isn't going to work. So I'm going to try the 1 with the 3, which gives me a 3, and the 2 with the 4, which gives me an 8. And that will combine to make a 5. Okay? But we have to remember that we want the positive 5. So which of these numbers has to be positive? Well, the 8 has to be the positive, so the 3 has to be the negative. So the 3 came from the 1 and the 3 being combined, which means that this 3 has to be negative. So I'm going to set up my my binomial parentheses and show that I need the 1 and the 3 to be combined, and the 3 has to be the negative. So I'm going to put my x here, my x here. I'm going to put my negative 3 here, which leaves this term as my 1x. And then I'm going to put my 2 on my other front, which I left no space for, so let me quickly rewrite this. And put my 2x in there. And then I know that I need a positive, and we know that it's a positive 4. And again, you know, I always tell you guys that you should check it. So you can box your answer, but then I would go back and I would check. And so I would check by saying x times 2x is 2x squared, and x times negative 3 is negative 3x, and a 4 times a 2x is a positive 8x, and the 4 times a 3 is a negative 12. So when I combine my like terms, I get 2x squared plus 5x minus 12. And that's what I started with. So this problem did check out. Okay, I'm going to do the next problem. And again, I want to factor something out first. So right away I can see that I have a cube on my x. Well, we're dealing with quadratics, which means that really we want to try to get rid of one of the x's. So I'm going to take these numbers to their primes. And I'm going to say that 8 is really 4 times 2 times that x minus 4 times x minus 4 times 6 times the x. And then what I can do is I can see that I have a 4 in each piece, so it comes to the front, and I have an x in each piece, and so it gets factored out and comes to the front. And then I make my parabola, and I'm left with 2x squared minus x minus 6. Okay, but because I still have an x squared, I want to try to see if I can factor that down to a binomial times a binomial. And so I know that one is going to be a negative and one is going to be a positive. Okay, so what we have to do is we have to figure out which is which. So I'm going to make my chart here, and I'm going to say that it has to multiply to make that negative 6. Okay, so one is positive, one is negative. It has to add to make the negative 1. And the first term has to multiply to make a positive 2. So my factors for the 2 are 1 and 2, and my factors for the 6 are either 1 and 6 or 2 and 3. Okay, so I'm going to go with, try with the 1 and the 2, and the 2 and the 3. So I'm going to say that 1 times 3 is 3, and 2 times 2 is 4. And so that is going to add to make a negative 1, but that means that the 4 has to be the negative. So in order for the 4 to be the negative, this 2 has to be the negative. Okay, so I'm going to put my negative 2 in here, and he has to combine with the 2 as the front term. Well, he's never going to combine with the front term here. He's going to combine with the front term of this binomial. So we put the 2x there, which leaves the 1x in this place, and it leaves the 3 here. And then, of course, this is our final answer, so we box it, but I would highly encourage you to check it and make sure that it works. I'm going to slide my paper up so we can see the last couple problems. And the last problem is x squared minus 100. Well, these are those special products that we talked about. It has no middle term, but I can very easily see that 100 is a perfect square. And so these, to get rid of the middle term, one has to be a positive and one has to be a negative, and the numbers have to be the same. So my x goes in my first place, and the square root of 10, or 100, is 10. So my 10 ends up being what's going to cancel out and make a 0 as a middle term. And of course, we're going to box our final answer, but I would check your work. So throw a check in there. All right, number 6. It looks like 9 is 3 times 3, but there's no 3 in 25. So this is probably as simple as it goes. So we're going to draw our chart and know that it multiplies to make 25. It's going to add to make a negative 30. And the first term is multiplying to make 9. So I either have a 1 and a 9, or I have a 3 and a 3. And for 25, I either have a 1 and a 25, or I have a 5 and a 5. And I can see right away that. Okay, 8th graders, so here's number 7. So 7 is x squared plus 17xy plus 60y squared. And so we're still factoring, but this is the basics. So we're not finding roots, we're just factoring. But when they first taught us factoring, they showed us that you could have 2 variables. And so one variable sits on this second term of each of the binomials, and one variable sits on the first term. And because these are both addition, right, it's an adding and an adding, you know that your signs in the middle are both addition. So we're going to make our little chart. We know that it has to multiply to make 60, and it has to add to make that 17. So we need to find our factors of 60. 60 is 1 and 60. It's never going to add to make 17. 2 and 30. It's never going to add to make 17. 3 and 20. Now that would add to make 17, but one of them would have to be a negative. But if we go back to our parentheses, neither of them have a negative sign, so that can't be it. So keep going, and we would have 4, and 4 goes into 6 one time with a 2 remainder, and 4 goes into 20 5 times. Well, 4 and 15 won't add to make 17, so keep going. We would have 5, and 5 times 12 will make 60, and 5 and 12 will actually also add to make a 17. So we're going to throw our numbers in. And this is our final answer. But, like always, you're going to check it and make sure that it works. And problem number 8. Problem number 8 wants us to factor completely. So right away I can see that they have an x in each term that can be factored out. But let's see if they also have a 3 in each term. So if I take 42 and I divide it by 3, because I know 3 is divisible by 3, and I know 15 is. Let's see if 43 is. 3 goes into 4 one time, and, oh, it's actually 42. And 3 goes into 12 4 times. So it is divisible by 3, which means that we can factor out a 3x right away. And we're left with x squared minus 5x minus 14. And now we have to leave our 3x on the front, but we need to factor completely this quadratic. And so we're going to make our little chart. It has to multiply to make that negative 14, and it has to add to make the negative 5. So I know one needs to be a positive and one needs to be a negative in order to add to make the negative. So let's go with our factors of 14, which are 1 and 14. And that doesn't work. 2 and 7 does. And the one that has to be the negative would have to be the 7 in order to add them together to get the negative 5. So I'm going to put my 7 with the subtraction sign and my 2 with the plus sign. And I'm going to box my final answer. And then I'm going to come down here and I'm going to do my check to make sure that this foils out to give me my original problem. Okay, that's it for today, guys. Make sure you bring your paper, all your work. Make sure you have your checks on your paper as well.